Howdy and welcome back. So let's go ahead and get started with some motivation for this idea of inheritance. I'll go ahead and say this might take a little while to set up, but I'm kind of confident that hopefully you'll see the utility of or where we're going with this by the end of this video. So let's go ahead and begin with this example of a truck. These are from my slides that I presented at Texas A&M and CS 121 there. The truck example is built up from Professor Moore's initial slides that I inherited. And I think it's a good example with some fun diagrams that hopefully illustrates the utility of inheritance and helps motivate it. So let's go ahead and just remember that classes can model things that are concrete. They can also model things that are abstract. And we'll focus on kind of the latter a bit more in detail within our polymorphism lesson that's forthcoming. But anyhow, remember that everything within our program is kind of an abstraction. If we're looking to model trucks, we're going to model within our application the things that are important to us while ignoring kind of the features or attributes that are of no relevance, within our particular application. So let's say we're looking of, I don't know, maybe we're writing a truck simulator. I have no clue, but we want to model trucks within our program. And yeah, we're kind of constrained by the example, but I think this will be kind of fun. So let's go ahead and just say, okay, consider a truck. This is a boring kind of just truck over here. It's not specialized. It's a generic truck, and probably what comes to mind when you think about truck. We're going to consider just, let's see here, 4 attributes. What is the truck's weight? What is the truck's fuel type? What is its length and height? And then we'll only consider 2 behaviors, forward and stop, just to try and keep this compact and hopefully focused. So now let's consider a fire truck. The fire truck is going to share many attributes and behaviors with our truck, right? A fire truck is going to have a weight, a fuel type, length, height. It hopefully can move forward and more importantly can stop. However, the fire truck is kind of a specialization of this generic truck that, over here on the left. So it's going to have some attributes and behaviors that are going to make it, say, a fire truck and not a cement truck. For instance, our fire truck might have these additional attributes, water capacity, how much can maybe it pump or how much water can it store if it's going out to fight a fire in a rural area. Some behaviors that it might have, which our generic truck wouldn't, would be the ability to start its siren, stop its siren. And I'm confident, there's a lot of attributes and behaviors that we are ignoring here. But again, this is our abstraction. This is what's important to us within this lesson. So there's our fire truck. Notice again that it has all the attributes of our generic truck, all the behaviors as well. However, it's specialized in the sense that it has some attributes and behaviors that the generic truck does not, which makes it a fire truck. So continuing to build this up, we're going down the same pathway now here with the concrete truck. So the concrete truck is also going to share many attributes and behaviors with this generic truck. It's going to have a weight. It's going to have a fuel type for its engine, a length, a height, hopefully the ability to move forward to get to where it's going, the ability to stop as it's approaching traffic or a stoplight or stop sign, et cetera, or its terminal location, et cetera. The concrete truck, though, is going to be specialized, like the fire truck, but in a different way. So it's going to have some attributes and behaviors that is going to make it a concrete truck and not another kind of truck like a fire truck. So in this case, our concrete truck might have, I don't know, concrete capacity. This is most of these are kind of poorly defined data members because they're not communicating the units to us. So if we look at weight, was that weight in pounds or some other unit of measurement? We probably should have communicated that information there. But again, let's just keep it simple and focused. And again, the importance of here isn't to be overcritical of, say, the data member names here, but to recognize that this concrete truck, it can do everything that truck can do, but it also has things that make it a concrete truck and not another truck, such as the ability to pour concrete. So the question is, how can we model this in our program? And the first approach might be, well, I'm going to make 3 separate classes. I'm going to have a truck, fire truck, and concrete truck. Now that's kind of going to be a lot of, copy and pasting, because if we think about it, these attributes and behaviors are all the same across each of our types of trucks. So the question is, can we do better and somehow maybe reuse these behaviors and attributes and functionality afforded to us by this generic truck in our specializations of a fire truck and concrete truck? Well, one approach might be to let's go ahead and make a super truck, a truck that could do everything. So let's combine all the attributes into one truck, and we have I don't even know what this is, but I overlaid all the little clip art on top of each other, and there's your fire truck, concrete truck, and truck all mixed together. And this just it isn't sensible. I mean, we do have this the common kind of attributes and behaviors here. And, we do have the ability to reuse them. However, it doesn't make sense that our our concrete truck is going to have a water capacity and a start and stop siren when it doesn't have sirens. Likewise, it's not really sensible that our fire truck is going to have the ability to pour concrete as well as a concrete capacity. I mean, obviously, if we went this route, we'd have to have many checks and somewhere an attribute that says, the type of object created from super truck is a fire truck, and then somehow restrict, the behaviors to the type of truck that is stored in that attribute. And that seems very messy. It seems very, it seems to violate a lot of our assumptions in terms of, what is a fire truck? What is a concrete truck? It shouldn't have all these other behaviors encapsulated into this super truck. It should, we should have a type for our fire truck. We should have a type for our concrete truck. And then maybe we have some sort of generic truck from which, these trucks are derived. And that's where we're going with this idea of inheritance. The idea is that we're going to, I don't know what happened up here, but this is going to be, I think, this got pushed. So that's forward. I'll go ahead and mark that out. But anyways, what we're going to do is we're going to create a class called truck, and we're going to put all the truck attributes and define all the truck behaviors within it. So we'll have weight, length, fuel type, height. We'll have, some sort of constructor that allows us to properly initialize those values, as well as, these generic behaviors, which all trucks can do, defined there as well. So the ability to move forward, stop, and probably other truck behaviors if we wanted a more complete example. Then what we can do is essentially say that a fire truck is a truck and inherit all of the truck functionality into our fire truck, and then add in a specialization to make that fire truck a fire truck and not a concrete truck. So effectively what's happening is you're able to create a fire truck that is both a fire truck and a truck because of this inheritance of the attributes and behaviors from what will be known as its parent. Likewise, the concrete truck will have it being a specialized concrete truck, but it's also going to support or inherit the behaviors from its parent, a truck. And again, its specialization would be additional, say, data members to store its concrete capacity, additional behaviors to define its specialization, such as the ability to pour concrete. And what we're going to see here is that in these inheritance schemes, how things are going to be set up is we'll have some sort of parent or base class, which will kind of put together all of the behavior, the generic behavior, or the behavior shared amongst the children or derived or subclasses. So in this case, we've looked at the commonality of our truck, and we came up with, these functions, these data members here. And again, we just isolated it across our two specializations of that truck. And we've simply picked that up and we've defined it within the base class, because that should be functionality and attributes that are shared irrespective of the type of truck we're interacting with. Then what we've said is, okay, we're going to have children that are going to derive from this. So they'll pull the implementation from the parent. They'll be able to we'd be able to ask our fire truck to move forward, and the definition of forward that it would use, provided it has not defined one, would be that of its parents. So we'll go ahead and get into how to set this up and some of the utility. And I think by the end of this lesson, it will hopefully be clear as to how we can really put our generic stuff under one class and then have other classes uh, derive from it so that we are not copying and pasting our definitions. And we'll see some of the other benefits of inheritance here as well. One key thing you should recognize at this point is if they're inheriting the common truck things from truck, oops, didn't mean to do that. If they're inheriting the common truck things, it's guaranteed that every child truck is going to have these attributes as well as support these behaviors. And we'll see why that's cool here shortly. So inheritance, again, I know maybe I got a bit ahead of myself, but many things share common features with other things, the extent to which is going to be dependent on the level of abstraction for which we reason about them. We can use the process of abstraction to encapsulate the commonality of those things into a base class. So that's what I was hopefully, effectively communicating on the last slide. Lower level abstractions of the things comprising this base can be derived kind of through these subclasses, which will allow us to implement specializations and complexifications to that kind of base foundation afforded to us by the parent base class. So with that, let's go ahead and get into inheritance here in the next section. Hopefully that was a bit motivating. We'll see.